Hello, everyone. You are welcome to today's lesson. And today's lesson, okay, is going to be a very short one. We are going to look at the solution to the first relative math assignment on coordinate geometry, what one. Okay, so as you can see, okay, we are asked to find the perpendicular distance from this point to this line. So the equation of the line is given and the point, the coordinate is also given. Okay, or the coordinates are given. So solution, that's the first thing that you write after reading the question, underlining any salient part. There is no salient part. If you want to, then it's perpendicular distance. That's what you're asked to. So you write given. And remember I told you the information given here, okay, always give it in what? In a pictorial form, in a diagram form. Extract it as such, because usually in geometry question, especially, yes, okay, 1 and 2, coordinate geometry 1 and 2, usually if you can sketch, and marks will be given for the sketch. Okay, so the sketch will always make your work very easy. However, please, you don't draw, okay, as for this one, I've told you, you don't draw in ink. Okay, some of you, I pardoned you because maybe I assumed that particular time you didn't have a pencil with you. So you don't draw with your free hand too. And equally, I pardon some of you. So your lines must be drawn using a ruler. Okay, then your diagram, the lines must also be drawn in pencil. Take note. However, remember I told you that your diagram here, under normal circumstances, is supposed to be a vital rough work. But if you are bringing it as a main work, okay, make sure it doesn't consume, okay, much of your space. And by that, this is what I mean. I remember I told you the maximum 3 lines will do, okay, for your vertical line. Then, okay, where the third line is, that's where, okay, your horizontal line will be, so that you can save, okay, some space for the major work that you have here as well. Okay, so please take note. Some of you, your diagram was too huge. Okay, so we are giving a point. So you indicate the point here. So here at the normal circumstance, the point is here. You are finding, okay, this is your point, and the coordinates of the point you know. And the equation of the line is also given. Remember, I told you, you write it, or you can even write it on top. Okay, however, what you are going to compare will guide you. This one is not necessary for you to write it, but the information here, the equation, you have to. Okay, however, I told you to write this because it will guide you as to how you can compare the form that you are supposed to leave your equation, okay, of the line given. Okay, so in this case, this was what I was giving. So when you are drawing and indicating the information, please indicate the exact information. You indicated the exact point here. So when you are indicating the equation to you, indicate the exact equation. Don't indicate the transformed equation. Take note. So after your indication of the exact equation, then now if you know you are going to compare per experience, you are going to compare this one with the general equation of a line. So general equation, which is the standard equation, everything must be on one side equated. So that will tell you that you need to move these two terms to the side. Okay, failure to do that, okay, will not make your A, B, and C precise. Okay, so it will spell doom. So take okay notes of that. So you move. So at this point, you know, like I said, you'll be comparing oranges and oranges. At this, if you compare this and this, it will not be possible. I mean, you'll be comparing oranges and apples. Okay, because they are not in the same form. So take notes, I'm repeating, so that next time you don't, okay, do the same mistake. So I've addressed some of your concerns there. Okay, and again, I told you when you draw your lines, don't forget to indicate the 90 nature of what you have there. So at this point, okay, there's a formula where perpendicular distance is a formula where, so just go and quote the formula. So formula I write there for the perpendicular distance D is equal to, you quote the formula, AX sub 1 plus BY sub 1 plus C. In some books, you see AH, okay, plus BK or AK plus BH plus C. Okay, in that case, they refer to their points, okay, coordinates HK. But I didn't use H and K. I use S sub 1, Y sub 1. So you go by that. And you can see that in the previous presentation, okay, because we're not mature, we said, but then you go and get your A or your substitution. So A, B, C, X sub 1, Y sub 1. Okay, so you can see that here I didn't do that. I extracted that as my rough work, which you could do. Okay, so what is important to substitute the values? I wrote but because I wanted you to get, okay, the values of whatever your parameters that you need to go and substitute. So here I went for x sub 1, which is 2, y sub 1, which is minus 5. Okay, then if I compare, my a is 2, b is negative 3, and c is what, 7. So this will be my rough work. I can strike it out. Okay, at this point, I come and what? And substitute. So please take note. So if you substitute and don't forget the absolute value, immediately you forget the absolute value, then it means you didn't code the formula right. So the person, you know yourself. Okay, I stressed on the absolute value in the numerator, and I even told you that in books, okay, they extend the absolute value to cover the denominator as well. But I advise you not to extend, because this usually will strictly be positive. If there will be negative, it will come from the numerator. So if you substitute and you come and simplify with the absolute value there, it will be 4. This time, this will give you 15, then plus 7. Then you come and add this with the absolute value still there. Okay, so that will give you absolute value of 26 over root of 13. Okay, so at this point, what do you do? Okay, you now come and remove the absolute value. That's your next step. So the absolute value in the numerator, if you remove it, 26 will still give you 26 positive all over root of 13. But okay, ordinarily you would have concluded here, but you know this is a fraction, okay, containing a z in the denominator. And when you did z, okay, you were told that you don't leave a fraction with a z in the denominator. So this should tell us that we need to rationalize, which most of you did. Okay, some of you use your calculator to get the answer. But so if you do that, I'll write how. So in this case, please don't rationalize at this point. This is a step on its own. The step that you are going to rationalize, you write this again before you multiply. Okay, most of you who did the writing, you skipped this step. Okay, you did your multiplication here. So it means the marks here, okay, will be gone. So take note of that. So at this point, numerator, denominator by the z in the denominator, which will give us this. So that will give us 26 root of 13. Then you get root of 13 times root of 13. That will give you root of 13 squared, which is what? 13. If you end here, then it means you are careless, because you should know that 26, 13 can go into 26. Even if you have any doubts, feed your calculator with this. Your calculator will give you the reduced version. Okay, so this will go here too, and you get 2 root of 13 units. Remember, therefore, you see, I've already drawn my conclusion. If you didn't write therefore, then you are now going to draw your conclusion. Okay, but I will, okay, plead. If you didn't write therefore and there is nothing here, go back and write therefore here, so that, okay, you save the time in drawing for the drawing of the conclusion. Okay, but again, I remember I told you that you avoid decimals if possible. So I don't know why some of you change this one to a decimal representation. This is the exact distance. If you use the decimal, then you are giving us the approximate, okay, or approximated distance. Okay, so the exact distance is usually preferred. And again, okay, you cannot ignore the unit. You are dealing with distance. Every distance is supposed to have a unit. But here, like I said, we don't know the exact unit, so you attach what unit to it. If you know the exact unit, you attach the exact, okay, unit there. I guess my point is well made. Hello, is my point well made?
Yes, sir.
Okay,
Yes,
so
please.
this is it for the classwork. Now let's go and look at the homework. Okay, so the homework, okay, was about collinear. Okay, so collinear. So this was the homework. Okay, so you are asked to determine whether or not these 3 points, okay, are collinear. Okay, and I remember I told you in the video, if the points, okay, they don't come with a name, okay, give it a name. Okay, it will make your presentation better, because your gradients will be gradient joining certain lines, so that your presentation we can easily follow. It will be coherent. Okay, so at this point, I have seen that my points didn't come with a name. Some of you will extract like I did. Given this, then you come and write less. Remember, I've told you this. Okay, just even in the polynomial, I told you, if the polynomial function is given, okay, and it doesn't come with a name, and you know that you need to feed that function, give it a name. But in giving your function a name, you can either write given and extract the function straight away or start with let. So it's the same thing. You can write given this, then now come and give your point names. Or you can ignore the given and start with the let. So let A be this point, B be the second point, and C be equal to this. So the point now, I have given the point names. Okay, so now that I know the names for the points, or I've given the point name, now I need to know the condition for point to be collinear. And what will be the condition for collinear? The gradient of what? The line joining AB should be equal to the gradient of the line joining BC, the adjacent points. Okay, and I told you that, in terms of notation, we cannot use capital letter to represent a gradient. So if you do that, I will underline. And if you don't define this, as A, your point A, your point B, your point C, then I don't have to see A, B, and C anywhere here. Because if you write MAB, there is no A. I can't see A, I can't see B, I can't see C in your presentation. So which one is representing A? So in that case too, I will underline. Okay, so take note of that. I'm addressing, some of your concerns. Okay, capital letter, usually we use capital letter to represent points. Okay, so it will be a small letter, then your point, will be A, B, and A is a point, so capital letter B is a point. Okay, so take note. You don't represent gradient by capital M, by a small letter. So those of you who did that from the beginning, you started with a problem. So at this point, we go and find the gradient of AB. Take this one, find that. So MAB will be equal to, so now you are looking at this. The point here, the first point will take your x1, y1. The point here will take your s2, y2. So gradient is change in y over change in x. And the formula, you can quote it in letters or you can quote it in what? In values, because you know the values. So in this case, change in y will be y2, which is 3, minus y1, so it will be minus 3, so it will be plus 3. All over. And I told you in the video, or I have even told you that whenever you are substituting, you don't substitute mixed fractions. Change it to the corresponding, or mixed numbers. Change it to the corresponding improper fraction and substitute that one. You remember I've told you this. So those of you who are substituting the mixed numbers, I was wondering, what happened to that advice? Okay, so now this is it. If you change this one to its corresponding mixed numbers, improper fraction, we are going to get minus 13 over 2. So it will be your x sub 1, which is this, minus your x sub 2, which is 7. So now numerator, you add, that will give you 6. Denominator, you can use your calculator to do, the denominator straight away, but not everything straight away. Take note. So if you use your calculator will give you minus 27 on 2. Okay, so this gives you, now that you've expressed numerator, denominator as a single fraction, you can use your calculator to do the whole of this, if you like. So calculator to do the whole of this will give us minus 4 on what? On 9. And please take note, those of you who did not use your calculator but you did it mentally, have told you, if you have maybe 4 over negative 9, you cannot end with this. You don't leave a fraction with a negative in the denominator, so bring it up so that it becomes 4 on what? On 9. And you can see that never in my presentation have you seen me writing more than an equal to on the same line. So my next step, which is the equal to, comes down, and I always write close to the margin, just as I've advised you. So I'm equally going by that advice. Okay, so you come and do same for the BC. And MBC, which is the gradient of BC, will be equal to change in y. So it will be 1 minus 3. That is y2 minus y1. Then x2 minus what? x1. So minus 2 minus this, so it will be plus. We change this one, which gave us a 13 on what? So this will be minus 13 on 2, but because of the minus and the minus, so it will be minus, changes to plus. Okay, if any of your gradient is wrong, you draw the wrong conclusion. So even if you draw the right conclusion, because one of your gradients is wrong, we won't give you the conclusion mark, because you are using the wrong data, to draw, a conclusion, automatically it should be flawed. Okay, so again, use your head to do this one, whole numbers we can. So that gives us -2. This one, you can use your head or your calculator. That will give you 9 over what? Over 2. So at this point, use your calculator to do. That gives you -4 over 9. If you compare, they are the same. So once they are the same, what do we do? The gradients are the same. So our condition is satisfied. So we draw the positive conclusion. Therefore, the points are collinear since MAB is equal to MBC, since your condition here is satisfied. As simple as that. So don't go and write therefore and come in and label, give all your points. We know the points. So don't come and write therefore 7 minus 3. You like writing a lot of English. I don't know. Okay, so be precise and concise, as simple as that. Okay, so now what do we do? The point, just write. We know the points. What are the points? These are the points. Simple. Okay, learn to use your time judiciously. So this will be it in terms of the solution to the second assignment. Any questions before I finally bring the curtains down? Any questions? Is the explanation okay? Is there anything that I underlined, I circled? Okay, I put a caution mark there, exclamation mark, that you still can't relate why I did that. Okay, so if that's the case, then this brings us to the end of what this session. Once again, God bless us all.